Lovely. Hi, so I'm Kirsty, and I'm a PhD student at the University of Manchester, and today I'm going to talk to you about my research, which is exploring the application of artificial intelligence to humanitarian mapping. So just to start, I want to get a bit of brief background as to why the research. So globally, there's an inequality in map data. So high-income countries, technologically advanced countries, they benefit from up-to-date, high-coverage data, whilst lower income, technologically disadvantaged countries suffer from a paucity of data. The reasons for this are manifold, but they include the historic control of information, the stronger socioeconomic status of certain countries, and the digital divides. And these inequalities are reproduced on national scales. So you've got high density in urban areas, whilst there's a lack of data in rural areas. So the relatively lower population in rural areas exacerbates these inequalities, and with fewer and less varied features in these rural areas, mapping can be boring and repetitive. And map data is really vital for responding to humanitarian crises. Without the data, we don't know where people live and how assistance can reach them. And it's often these countries that are most at risk of humanitarian crises that are the ones that are suffering from this paucity of data I just discussed. And more specifically for the research, it was developed to help address an observable chronic humanitarian problem, which is major limb loss in the Acholi subregion of Uganda following a 20-year conflict. And to help reach these people suffering from major limb loss, the Gulu Referral Hospital collaborated with the University of Manchester to set up an outreach orthopedic clinic. However, lack of map data challenged the success of this clinic. The most recent maps in this area date back to about 1969, created using imagery from the 40s. And although the research has been successful in increasing data production, large areas of Acholi remain unmapped. And the research was also motivated by observable challenges with humanitarian mapping platforms and engaging with them. So currently, a lot of the humanitarian mapping is done via OpenStreetMap, most widely using its online platform ID. But ID is widely reported as quite prohibitive to first-time users, which is supported here by some anecdotes from participants in my study. So then how can machine learning help these machine-human workflows? So by taking on the laborious repetitive tasks, such as digitization, volunteers can then concentrate on higher value contributions, such as thematic labeling and verification, which can help them to feel more productive and engaged with mapping. And by introducing AI into the workflow, we can potentially attract volunteers that are interested in machine learning, but also potentially lower entry requirements to attract volunteers who are less confident with mapping. And by allowing them to concentrate on these more meaningful tasks, this may lead to higher quality contributions. But before we apply machine learning, it's really important to understand some counter arguments. Many people highlight uncertainties around the black box nature of algorithms and machine learning, which can lead to blind trust and us deploying them without rigorously evaluating them. And currently evaluations tend to only look at accuracy and performance rather than how users experience interacting with the machine, how they engage with machine learning, and the value of the data that's produced. And this black box nature also leads to discussions around systematic biases. So algorithms can often reflect the biases of their creators and the data they're trained on, which means the outputs and conclusions that we draw can also be biased. And due to this dominance of algorithm development in higher income countries, they're often non-local and lack specific context, which then is highly problematic in the context of humanitarian mapping. And machine learning algorithms also require a lot of training data to perform well, which can be difficult in these areas that don't have data. And then VGI communities, in particular OpenStreetMap, are often quite cautious towards machine learning, and guidelines mean that every feature needs to be verified before upload, which means very few of these machine learning studies that exist actually result in data uploads, meaning they're just kind of contributing theoretically rather than helping to reduce these inequalities. So what are we proposing? So Centaur VGI, it's a framework for augmenting mapping with machine learning, and the machine's tasked with identifying geometries and the human with approving, editing, or rejecting these geometries. It's an iterative process, so then the machine can learn from the human and become more accurate and specific over time. And the name, for a bit of background, is derived from Centaur chess, where gameplay is augmented by a machine. So how do we navigate these critiques with Centaur? So Centaur should be viewed as an assistant It's not a way to replace people, but a way to augment their mapping. And by making sure humans are involved, this increases our understanding of the algorithm and provides space for us to question it. It provides a gap for us to see into that black box and reduce concerns around uncertainties. And it also makes Centaur a middle ground between the OpenStreetMap and machine learning communities. And there's the possibility for building in active learning, which helps to further involve the human in this process. And then reduces also the need for large training sets and can help us refine and localize algorithms. Centaur can be applied with any combination of algorithm, target location and feature, which should be chosen to match the context that it's being applied to, and can also be purposely developed, which allows space for in-country development. And the algorithm can also and should be trained using local data. It can also be used with any map editor, which you can choose to reflect volunteer experience, which is again providing space for in-country development and also to help reduce biases and lower entry requirements. So can Centaur be implemented? So to evaluate this, I've built an online mapping platform with the purpose to map buildings in Uganda using this framework. And it was built with the intent to try and lower entry requirements to mapping, increase volunteer engagement, and increase data production. And it was built using JavaScript, PHP, and SQL, and it selected a machine learning detected geometry from a database, and then checked if it already existed in OpenStreetMap. If it didn't, then it was presented to the user for them to approve, edit it, or reject it. And then these approved geometries then were then uploaded to OpenStreetMap via the Overpass API. It was a relatively simple platform with a lot less editing capabilities than the ID editor. And it was evaluated by 34 participants to use the platform and compared it against an existing platform. So they used it for 10 minutes and provided a think aloud commentary as they mapped. They provided qualitative data about their emotions and thoughts while using the platform, provided insight into the user experience and emotional enjoyment of the platform. And after this, they answered a questionnaire with demographic and usability questions from a participatory GIS usability questionnaire designed by Balator et al. And then they gave further detail to their final 8 answers. And I'm going to calculate some performance metrics, but I won't present those today. So what have we found so far? So overall, participants preferred Centaur. The usability score was higher than the comparison. So there's a median score of 50 versus 48. And you can visually see that there's less variation with the scores for Centaur, with no particularly low scores for it, whereas there were some with the comparison platform. And this was confirmed by sign tests, where most of the participants were scoring Centaur higher. And so why did they prefer Centaur? The usability and the simplicity was often highlighted. They felt it was more appropriate for first-time users. It would be a way to introduce novices to mapping and then move on to more advanced platforms, which is important in the context of humanitarian mapping, which often attracts more newcomers and first-time mappers. They also felt it was more efficient and they felt more productive when using it. And if they wanted to produce a large amount of data, they'd use Centaur. Although they felt more productive, they often found it a bit more repetitive than the comparison, and said that giving the task of finding the feature over to the machine kind of took away feelings of discovery. And although it was less engaging for them, that was only relative to the comparison. And they still found Centaur to be engaging, which emphasizes the need for us to consider the engagement and improve that. And then finally, an interesting thing was that Centaur didn't actually end up producing more data than the comparison. I found that participants got quite particular when they were editing it, and they spent a lot of time making really small adjustments to the shapes, whereas with the comparison, they just quickly digitize and move on quickly and copy and paste features that weren't the right size. So this links to that kind of idea of the quality mediating potential of machine learning.
1 minute.
So to summarize, I found Centaur can be successfully deployed to provide a user-friendly experience and get machine learning data uploaded to OpenStreetMap. They preferred Centaur, and although they felt more productive, the data didn't reflect this, but this research is providing groundwork to allow us for the development of other implementations with a focus on in-country implementations of Centaur. Although it's been successful, there's a few areas to work on. So further exploring motivation, which was a bit lower with Centaur than expected. So I'm going to look at gamification then refining it with trying to lower the entry barriers further, building active learning to help localize it, and then explore ways to integrate in-country development of the platform. Thank you.
So William McInnes is asking, can you summarize type 1 and type 2 errors in Centaur, i.e. how often was the user rejecting the Centaur's efforts?
Yeah, so I haven't presented it here. I have got the data. So when I was, so the way I built it, it was counting, and it was counting how many times they either said, yes, it was a building. If they weren't sure, that was counted. And then also there was a count there for when they were rejecting it. So this one, the idea behind Centaur was that you could, it should be with like a live machine learning service, but just so we were exploring like the user experience. It wasn't live, so it was pre-generated geometries, but the idea is that it would build that into the learning process. So then when it was rejected, the machine would learn. But I have the data, but I've just not analysed it yet.
Lovely, definitely something for people to keep an eye out then. I'll switch over to Sarah. Are you aware of / making use of MapSwipe? It's potentially a great source of training data.
Yeah, so yeah, I'm aware of it. So I know I have it on my phone as well. Sometimes I like to play it. But yeah, no, that's because they're building the machine learning. So I've looked at some of the research that they're producing from Heidelberg. But yeah, no, is, as you say, a very good source of training data.
Nick Ham, did you find evidence for the potential problems that you mentioned, systematic bias, etc.?
Not so much with, I guess not with them being there, but I think something I did find that I didn't talk about so much here was, I think with the systematic biases, what kind of I did start noticing people were starting to kind of question why the algorithm was doing things. So, you know, oh, maybe it's done this because of this reason. Oh, I think it's detected this part. But they're really using it for 10 minutes. So I think potentially with a bit more time, they'd pick up on that more and then be able to kind of recognize why the algorithm was doing things wrong. And then kind of like thinking about how we could change the training data. Because it's Microsoft's geometries that detected, which is for the whole of Uganda. But I think, but yeah, I kind of noticed it, but not so much.